Hi students, let's look at this question here which was taken from one of our mock paper. So you're told to actually, with an aid of a sketch, show that all the rectangles inscribed in a circle, the square has the maximum area. I think this is poorly done by students, but basically before you even start, you must understand the idea of application of differentiation. So if you look at in our summary notes, right, I've already spoken many times during class is that you must always be able to identify two variables. Sometimes it's one variable or two variables. And also there's usually a fixed condition to be able to relate these two variables and see how you can actually, just relate them and then try and solve the questions as per normal. So I think without further ado, let's see how we can solve this proficiently. So there are many methods here. So I'm just going to touch on two main methods because any other methods typically just revolve around a variation of this, okay? But as long as you get the idea correct, then it's fine. Now with the aid of a sketch, so method one, we talk about just using geometry. Okay, this is geometry. So I think this is, or you could just use Cartesian form is fine. So it's the same. We have a circle. So if given a circle, we are told to show that actually any kind of rectangle which is inscribed in a circle, which is here, would actually be, be a square. Maximum area, the one which gives us the maximum area will be the one, a square, which is a square. Okay, great. So this is a rectangle here. Just try not to draw it as a square. So try and understand what is a variable first. So we know many times in class I've mentioned that anything related to circle, the radius is actually very, very important, right? So I'm going to try and relate the radius here and try and see what is the variable. So this is actually the midpoint, and actually we have got a radius here. Okay, that's pretty okay. Now what we're gonna do is actually just identify what is the two variables that we have. So the two variables is actually the height and width of this, right? So we could let this be this is x and this is y. Okay, so this will be two. Now the radius shouldn't be the variable because radius is actually fixed. Like any circle, the radius, they are similar, so the radius is actually a fixed constant. Okay, so the two variables is actually x and y. So let height be x and width be y. So this is x and y. Whereas a constant here is actually r, the radius, and let and radius be r. Okay, so like that. Great. So once this is done, it's pretty okay. Then after which, what you need to show now is important, because if you do not know what you need to show, it's going to be, you need to show that x equals to y when a is maximum. Okay, this is the important part that you need to be able to tell. So if this part you're not too sure, please make sure you understand this part here, because it will only be a square if x equals to y and y equals to x. That's pretty okay. Then after which, what we're gonna do is actually we're gonna start doing we're gonna find a condition which relates both the variables. So condition which relates both x and y will be the Pythagoras Theorem. So we know that by Pythagoras Theorem, we know that 2r squared equals to x squared plus y squared. Alright, so that's pretty okay. Then you could actually just find, hence the area. Area A is actually just xy. That's okay, right? Then what we can do is actually just going to put, this is actually x squared equals to 4r squared minus r squared. So we have a equals to y square root 4r square minus y square. So I don't really like the square root, so I'll just square both sides and use implicit differentiation. But you can differentiate this straight away, it's fine. So I like to use implicit differentiation because it is better in the sense. So in this case, implicit differentiation, a square equals to x square y square. So generally I will get a square equals to 4r square minus y square and y square, and this would be actually be a square equals to 4r square y square minus y to the power 4. Okay, this is a pretty nice one. So differentiate with respect to y, it doesn't matter because now your variable is in terms of y. So 2a dA dy equals to 4r square, so 8r, r is a constant, so 8r square y minus 4y cubed. Okay, so that's pretty okay. Now once that's done, we need to show that is maximum later, but we will show later. We need the second derivative. Actually, should we show? Okay, so as stationary value, maybe I just differentiate with respect to x. Okay, never mind. We just as stationary value, stationary point, dA dy equals to 0. So we know that this will be 0. So 2a 0 equals to 8r square minus y. Okay, so this case here, 0 equals to 4y. This will be 2r square minus y square. Okay, so this case here we have y equals to 0 or y square equals to 2r square. Okay, r square or 2r square. So we know that y square equals to 2r square. This one reject, as y has to be bigger than 0. Y square to 2r square would mean that you sub this inside here. This will mean that x square equals to 4r square minus 2r square. So this will be 2r square x square. Okay, so this is actually y square. So hence x square equals to y square, and you can just write x equals to y. Okay, there you go. Now, in order for you to show its maximum, I think it's not really a big deal there. What we're going to do is actually showing maximum. It's max. Okay, we could just differentiate again. So differentiate with respect to y. What we can get is actually just implicit differentiation. That would be quite good. So this will be 2a d square a dy square plus dA dy times 2dA dy equals to 8r square minus 12y square. Okay, so then once this is done, we're just gonna let y square equals to 2 square. So this case here will be 2 square ay plus 2 dA dy. Obviously, when dA dy equals to 0, y square equals to 2r square. So this is 0. This is 0. Everything is 0. So 2a d square a dy square 8 r square minus 12 2r square. This would just be 8 minus 24 would be 8 minus 24 will be negative 16r square over 2a. Okay, so this is actually because r square is positive, since a is positive and r square is positive, hence a is maximum. Okay, thus a is maximum when x equals to y, which means rectangle is a square. Okay, that's how you show this question here proficiently. There's actually a faster method, so I think this is generally something which students will think of first. Let's see how we can do the other method there.